Okay, 10.3, card sort, angles, arcs, and radii. I'm going to give you a set of cards, and I want you to sort these cards into categories of your choosing. Be prepared to explain the meaning of your categories. Then sort the cards into categories a different way. Be prepared to explain the meaning of your new category. So obviously this is slightly difficult to do remotely, but we're going to try and do our best. So I have all these cards labeled A, B, C, D, E, F, G, H. And what I'd like you to do is, however simple or complex you want to make it, how could you pair off these cards? And it doesn't have to be a pair of two. It could be a group of 3, 4, obviously not 8, because that would just be all the cards together. But how could you pair these cards up so that they make sense and they have a label for the category they're in? So think about that and a justification for why you paired those cards together. Okay, well, I'm going to go over what it's probably the most straightforward pairing. And if you did this, great. That means you're definitely on the right track. Okay, so I think the most straightforward would be card A and F. Because as we can see with card A and F, they both show a circle, they both show an arc length, have a central angle. They're a little bit different, right? This one looks like it's a major arc, and this one's a minor arc. But they both, show a diagram, so that's why I'm going to pair those two together. And then another, sort of straightforward one, D and E, they both have an angle measure paired up. So that's why I wanted to put those two together. I'm guessing it's a central angle since we're talking about circles. Could also be the degrees of the arc as well. Well, that would be equivalent, right? Central angle, whatever the central angle is going to be equivalent in degrees to whatever, however many degrees the measure of the arc is. All right, and then the next 4, I just sort of paired together all together, right? These 4, they all give an arc length and a radius, in units. They don't specify what type of units, just units. So that would be my more straightforward way to pair it. Now, I'm sure many of you feel like it's sort of odd to compare these two, because like I said, one's a minor arc and one's a major arc. So let's split them up, and this is sort of a second way we can pair them up. And of course, if you find a different way than any of them I've suggested, feel free to share that. That's awesome. Okay, so I'm going to put card A over here on the left and card F over on the right. Okay, now I'm looking at these two angle measures. I know I say never assume an angle measure based off a diagram, but for the sake of this activity, it seems like they want us to do that. So I've got 270 degrees, which I know it's not obtuse or acute. It's actually a reflex angle. And what that means is, like see how we have a 90-degree angle right here? The rest of the measure is the reflex on the other side, and that's 270 degrees. So that's what I'm going to put right here. And we know 270 is like 3/4 all the way around, right? If we're talking about 360s all the way around. And here it appears to be 3/4 around as well. Card F, 45 degrees. Well, 45 is equal to, 90 divided by 2. So if we look here, if we sort of make a makeshift right angle, it's almost like we've cut that in half. So that's how I see that to be 45 degrees. Okay. So now we got to think about how are we going to assign card B, C, G, and H. Where do they belong? Do they belong with card A or card F? All right, so take a second and think about, if I'm looking at card A, 270 degrees, which one of these, and it could be multiple, also makes you think that it's talking about a circle where the central angle is 270 degrees? What arc length and radius lead you to believe that that's what's happening here? Okay. Now, do any correspond to card F and card D with 45 degrees? Out of B, G, C, and H, which of these would belong with a circle whose central angle was 45 degrees? Okay, so like we talked about in the do now, it's never enough just to know arc length, right? Because we were talking about bigger or smaller circles, that arc length could mean a lot in a small circle and not so much in a big circle. So what we talked about in the previous activity was sort of ratios between these lengths would be much more beneficial. So let's look at the ratio for each of these. So if I'm at card B, I'm going to make a ratio of arc length over radius. So that would be 4 pi over 16. Now some of you may realize that while that's a correct ratio, it can also be reduced. Right? If I divide the numerator by 4 and denominator by 4, since they have a common factor of 4, I can reduce it. So 4 pi divided by 4 is just pi, and 16 divided by 4 is 4. So this ratio is equal to pi over 4. Let's test out another one. And just looking at these, if I'm thinking about getting the same ratio, pi over 4, I notice that I've got 4 pi over 16, where 4 is very clearly smaller than 16. So if I look at some of these other ones, like 12 pi over 8, 15 pi over 10, that numerator looks larger than the denominator. So I'm going to stick with card H here, because I see it's 6 pi over 24, where 6 is smaller than 24. Just trying to save myself some time organizing this. All right, so think about what would I divide the top and bottom of my fraction here to reduce it. And I see 6 pi and 24 both have a common factor of 6. So I divide 6 pi by 6 to get just pi. Now I divide 24 by 6 and I get 4. So again, we get pi over 4. So B and H are going to be a pair. I'm not sure which one they refer to just yet, but I know that they're definitely a pair if they have that same ratio. Let's try with card G. 12 pi over 8. These both have a common factor of 4. 12 pi divided by 4 is 3 pi. 8 divided by 4 is 2. All right. Now for this one, do 15 pi over 10. They both have a common factor of 5. 15 pi divided by 5 is 3 pi. 10 divided by 5 is 2. So we see that this also has a common factor, a common ratio of 3 pi over 2. So think about those two ratios. We got pi over 4, which is roughly 3.14 over 4. And then 3 pi over 2, which I guess if we convert to pi to about 3, it's around 9 over 2. So here we got about 3 over 4, and here about 9 over 2. So if those are the ratios, can we think of some way why we can justify C and G belonging to either A or F, and B and H belonging to either A or F? All right, so hopefully you realize that if I have a larger ratio of arc length to radius, that means that the arc length that has a larger radius is going to be taking up more of that circumference. So 3 pi over 2 is going to refer to the 270 degrees, and pi over 4 is going to refer to the central angle that's only 45 degrees. All right, and let's sort of look into why this is the case. Okay. So let's say, rather simply, let's make this radius equal to 1. All right, we know that the central angle is 90 here, or is 270, sorry, 270. All right. Actually, you know what, let's pretend we don't know the radius, sorry. I'm gonna leave that as R. So all we know is that the central angle is 270, and that we've got some length here for the arc. So let's set up a formula. We know that length is equal to theta over 360 times 2 times pi times R. And you'll notice that when we got this ratio here, we made a ratio of arc length over radius, so really L over R. So I'm going to try and recreate that same ratio. So to get L over R, I want L to be divided by R. So I'm going to divide both sides of this equation by R. And we get L over R is equal to this whole side. We just cancel out those two R's. All right. Remember, we said the central angle was 270. So I'm going to put 270 in for theta times 2 pi. Well, 270 over 360 looks like a really nasty fraction. In reality, it's not that bad. 270 divided by 360, right, it's just 0.75. Let's have as a fraction now, because when we talk about ratios, we want to see fractions. So if I convert that to a fraction, it's just 3 over 4. So we get L over R is equal to 3 over 4 times 2 pi. Let's just make this simpler, right? L over R, and really this is 2 pi over 1. So 3 times 2 pi is equal to 6 pi over 4, which I can reduce even further. Divide top and bottom by 2. 6 pi divided by 2 is 3 pi. 4 divided by 2 is 2. So we get that ratio of 3 pi over 2. No matter what radius I have, so that no matter how large or small my circle is, as long as my central angle is 270, I always get that same ratio of 3 pi over 2. Let's look at the other circle now. The other circle, we had a central angle of 45. So L equals 45 over 360 times 2 times pi times R. We're going to do the same thing. We're going to divide both sides by R, so we get our nice ratio of L over R. R's cancel out. 45 over 360, 0.125. Let's convert that to a fraction. 1 over 8. So it's really 1 over 8 times 2 pi. All right, multiplying these two fractions together, because it's really 2 pi over 1, we get 2 pi over 8. Common factor of 2 in the numerator and denominator. So we divide the top by 2 and get 2 pi divided by 2, or just pi, and 8 divided by 2 is 4. So we get the same ratio of pi over 4, no matter what the radius is. If my central angle is 45, the ratio of my arc length to radius will always be pi over 4. All right, so depending on that central angle, we can see that central angle has a direct correlation to arc length and radius. All right, that's all for 10.3.